be asked to speak at today's British Computing Society International Conference alongside such eminent speakers. So welcome to my talk on quality assurance as a cybernetic process. I'll be talking about framing quality management for complex systems, human conduct, and ethical artificial intelligence. Just a little bit about me, as Ray said, I'm a strong advocate of responsible use of artificial intelligence all the way from our personal lives to our professional lives and how we teach our children. Today is going to be focused on the professional part of it. I'll just go to an overview of what I'm going to cover today. So I've time boxed a few elements. We're going to start with an interactive exercise. This is to make it fun. Don't take it too serious. I will be going through a survey of 20 questions. The purpose there is to get the audience point of view as a pre-lecture survey, bit of fun with AI. I'll be asking some controversial questions, but please have fun with it and take it too serious. I was intending to take the responses in the chat and put it into AI and extract 4 common themes that I would address at the end of this. However, given data restrictions on today's Zoom, I won't be able to do that. I have done a simulated version using AI to pretend to be a group of 30 people answering 20 questions. So I'll use the responses I got out there, but we'll still go through the exercise. So that'll be the first 10 minutes. Then I'll go into the cybernetic view of quality. That's Pyrrhos's cybernetic view of quality, and what I've framed as 4 layers of quality assurance today. In those 4 layers, I will be referencing the Australian government architecture for artificial intelligence, as well as the methods for ethical artificial intelligence in defence, pragmatic tools. Caveat up front, I'm not representing the government today. This is a professional hobby of mine, if you will, researching into adopting AI, and this is the view of myself, Director of Missing Link Solutions today. At the end, I'll bring it all together and see from the initial exercise, have I provided some pragmatic tools and methods that could be used to answer the urgent call for ethical reflection. So when we think about using AI for quality assurance, what ethical implications come to mind for you? If everyone can get their chat ready, get your chat box open ready, I'm going to start dropping questions in for the next 5 minutes, and I want everyone to swap the chat. Just while you're getting your chat boxes ready, I'm going to introduce 2 defined terms, that is artificial intelligence and cybernetics. For artificial intelligence, I'm going to use the Organisation of Economic Cooperation and Development definition. There's 36 member countries involved in sorry, it's playing with my thing here. Moving out of the way so I can read it. I'm going to read this verbatim. An AI system is a machine-based system that, for explicit or implicit objectives, infers from the input it receives how to generate outputs such as predictions, content, recommendations, or decisions that can influence physical or virtual environments. Different AI systems vary in their levels of autonomy and adaptiveness after deployment. Now, for cybernetics, found a little bit more difficult to get some formal definitions. Now, I only did some very quick research on AI. It gave me 10 informal definitions, 10 formal definitions, and I'll leave those up on the screen as I go through the survey questions now. So the purpose here is I was going to go through 20 questions and give about 10 seconds to answer each question. And if everyone can just drop in the chat answers to the questions. So question number 1. Should AI teammates be held legally accountable for mission-critical errors in areas such as aviation and healthcare? I'll give it 10 seconds. Okay, lots of good answers dropping in there. Next question. Can humans ethically delegate life or death decisions to AI in contexts like combat or triage? Give it 10 seconds. And feel free to add some words in with your no because, or no because you can't trust AI, or yes because you can trust AI. All right, lots of good responses. Next question. Question 3. Do opaque black box AI models have a place in critical QA? For example, in nuclear safety? Question 4. In life-saving systems, should explainability outweigh raw performance in AI outputs? So thinking about Tom Gilb's presentation around what was the weighted estimation tables. What do you weight more, explainability or performance? Where's the value? Next question. Should all AI decisions in QA be auditable and traceable, even under crisis conditions? So if you're under a crisis condition, do the rules change in your opinion? Does performance all of a sudden outweigh explainability if it means orders of magnitude difference in life or death? Very controversial. Question 6. In emergencies, is speed more valuable than retaining human oversight? In disaster response, if there are fires, if it is going to save lives, what is more valuable? Human oversight or disaster response speed? Some good balanced responses in that one. It's a shame I won't be able to use the actual audience's responses. This will be very good. Question 7, and getting up to close to time, so I'll try and speed it up a bit. So, should human conscience always override AI outputs when values clash? For example, in medical prioritization. Question 8. Does AI teaming risk diluting human accountability in shared decision systems? No. In what cases should humans always retain final decision authority over AI? I'll give this one 20 seconds and then I'll end on 10 questions since I'm going to use a simulation rather than chew up into more of the presentation time. Okay, final question. Should QA frameworks regulate how AI is used in applying lethal force? And pause for the survey. Thank you all for those responses. I see there's been a lot of responses in that. So unfortunately, I'm going to have to rely on a simulation I did just in case we fell into this scenario where I wouldn't be able to extract from the chat into AI. I've got a pre-organized prompt that I was going to use, including the task I wanted AI to do, the rules I formed on how it would focus on majority signals, collapse synonyms, ignore outliers, duplicates, and all the intelligent things that Larry Barkley teaches around how to do intelligent prompts, the output format and the title. I had a prompt. I said, then I did a simulation, simulate 30 people answering these 20 questions and give balanced responses, try and be unbiased. And it gave me all these responses with my prompt. And here is what it gave as 4 themes distilled from the audience chat, which I'm going to drop into the chat. And this is what we'll come back to at the end. So the ChatGPT output, the 4 recurring themes that were distilled from the simulated audience response were accountability and responsibility, that is participants, the virtual participants, well, not virtual, but synthetic artificial participants, stress legal and ethical accountability with QA enforcing clear responsibility chains to prevent blame shifting, oversight and human authority, strong signals favouring human retaining the ultimate authority, especially in life or death use cases. And lethal force regulation. Transparency and auditability. Black box AI was widely rejected. Traceability, explainability, and continuous bias testing was seen as non-negotiable for ethical AI. I'm really glad to hear that. And then ethics beyond compliance. So QA must integrate human values and conscience with enforceable legal standards and independent ethical audits in mission critical context. So those from the simulator response, and we'll come back to that at the end and see if we've addressed those points. Now I'm going to go into Pyrrhos's cybernetic view of quality, meta QA when the observer is part of the system, AI and autonomy when the system thinks back. I'm going to start with the theme of the conference, the ethics. So a call for urgent ethical reflection. What must we now consider in QA as a regulating system within a system of systems? So regulating the regulator, with AI being part of this loop, the recursive control of monitoring the monitor. Ross Ashby's law of requisite variety. So I was having that conversation with Barclay after his presentation around checking the checker. The system checking the system must have more variety than the system it's checking in order to meet Ross Ashby's law of requisite variety. And that applies for assuring AI systems. So we're at a point where we have a call for urgent ethical reflection in the face of growing technological power. Now, however, interestingly, in 1954, I got a quote from Norbert Weiner's book, The Human Use of Human Beings, Cybernetics and Society, and I'm going to read it verbatim. We have modified our environment so radically that we must now modify ourselves to exist in this new environment. The hour is very late and the choice of good and evil knocks at our door. And he said this in 1954. Where are we now in terms of technological power and the exponential growth of it compared to then? Makes us think. We must also think now when the observer is part of the system. So if the observer's AI and AI is part of the systems, humans are now agents within the complex system, no longer just the overseer of the system. We must consider the philosophical aspects. We must consider reflexivity in assurance. So a system is observing its environment, perpetually modifying itself. The system that's checking it must also adapt and continually modify to the changing model. We must audit the values and ethics, not just the data. And that was an interesting conversation in the break with Barclay as well. Okay, how do we measure behaviors? How do we measure ethics in a system which is, if you will, a drunken robot? It cannot actually think. It doesn't have mental states. It is pre-trained. We must particularly consider examples of high assurance roles where, such as systems engineering and quality assurance roles in mission critical environments. We must continually test those, continually check if the ethics have been applied correctly. And assurance itself must be adaptive when assuring adaptive systems. Okay, so now AI and autonomy, when the system thinks back, what do we need to keep in mind? The cybernetic view of quality, the shift is from deterministic to complete learning systems, stochastic models, probabilistic models. The QA implications for this, machine learning model drift. Per the diagram down the bottom there, the original pre-trained model and the decision boundary based on the data versus new data that it gets as it learns, it means the model drifts, the decision boundary changes. We must be cognizant of that and how we need to continually measure it. Human AI teaming on the right there. So yourself, your chat GPT or whatever other Claude program and what others as well, producing inputs together. There's a black box in there, there's a decision chain. We need to unpack that in more depth. Quality of training data, there's an ethical risk there again. How has that data been weighted? What's the parameters? What's the depth? How does the model behave when it forms its operations per forward pass? How does it retrieve, augment, and generate? The illusion of control when behavior emerges from algorithms. So we talked about that in some of the other presentations today, the illusion of control. It appears it is thinking, but it is an illusion. Now I'm going to go into the 4 layers of quality assurance. So these 4 layers being engineering, basically the design, the project, the program, where we test the models, the governance, where we assure test the models, the outcomes are meeting the standards, and then the 4th layer, which I've added, the meta QA, the auditing the auditor, the triggering remediation when QA itself trips. The way I think about these 4 layers is layer 1, bake the goodness into design. Layer 2, bake the goodness into test. Layer 3, bake the goodness into assurance. And layer 4, ensure the goodness is continually baked in. So let's start with engineering QA, the first order. So when I think about using AI in QA for systems engineering, it gives me goosebumps with the possibilities, the excitement of what we could use to do here. And I could talk with Barclay about this for ages around, using human AI teaming to form use cases, like the power of use cases, scenario development, sitting there with the end user, whatever your use case is for your application of AI, using AI to perform the functional analysis. That means we can now connect system structure and behavior and parametrics in a way that was previously not possible. We can start forming connections of abstraction from development testing to acceptance testing to operational testing in a way where we can design in testability from top to bottom, from the user need, the concept of why is something needing to be considered to be funded, down to the component specification level. Normally these happen in sequence. Sometimes they're a bit iterative and recursive. Now there's power to do even better than before. So for me, this forms the foundational link between verification and validation. And I got a quote from Larry's book, Barclay's book, I should say. Larry comes after. But Barclay's book, Engineering Intelligent Systems, for those who haven't read it, pick up a copy. It's really good. And Barclay's quote, use cases are nature's way of letting you know how sloppy your requirements are. Well, now with AI in the mix, our requirements can come even better. Our use cases can be linked to our requirements in a way previously not possible. There are tools out there, and I've recently seen a demonstration of IBM's Watson X tool. There is a QR code here, and I will be uploading these slides to the website. I think you can even reach out to IBM and they do a free demo. I saw a demo of this tool, and they took a set of needs and formulated them into requirements using INCOSE guidelines of goodness checks, such as subject imperative requirement constraint. Does it follow the goodness rules of what a requirement should look like? And then even formulated tests out of it. Of course, it needs the human in the loop to check it and all the subject matter experts, but it really does speed up productivity and create some amazing possibilities there. That's first order. Now second order QA. This is what I'm proposing as the missing link between verification and validation. So when I say verification, I mean, is the system built right? Did we build the right AI system for the right purpose, linked to the use case? Did we build the right system? So not just did we build it right, but are we validating that we are actually building what we need to use for what we need to use? Comes down to the use case again. So this needs to be applied over the whole life cycle. And I'm going to focus on 2 parts of the framework in the next part. The ongoing monitoring and test evaluation, T&E, which is connected to all other 3 layers. So we say this is the second layer, but what I'm proposing is the second layer is connected to the first layer, third layer, and fourth layer. It is the connective tissue. So the third and fourth layer, taking us towards a viable quality future. Starting with a governance framework. So I've referenced here the Australian Government Architecture Requirements as the framework, which includes 9 lifecycle elements, 42 statements, 148 criteria, 90 of which are required and 58 recommended. It's a very good starting point for when you're setting up a project or thinking about how you want to apply AI. The 9 stages shouldn't be thought of as sequential. They should be thought of as iterative and recursive. There's design, data, training the model, evaluating, integrating, deploying, monitoring, and decommissioning. Now, I'm going to focus on 2 of these. The center one there, monitoring the ongoing V&V as a verification and validation, or T&E, as I mentioned earlier. That needs to be thought of. What I'm proposing is right from the beginning. As soon as you start with your whole life cycle, you should be thinking about how you're going to monitor it. Then you go to data, you train, and the other one I'm going to focus on today, because at a limited time, is evaluate. That's another one. That's actually the first one I go to directly after we've come up with a purpose of the model. And I'll go through why shortly. So this presentation will be available to everyone with links, which I'll jump into one of the links and I'll start sharing that web page actually. So let me go back to there. And okay, can I get a thumbs up? You can see my web page. Yep, cool. Okay, so this is the technical standard for the government's use of artificial intelligence website. Links are in the presentation for starting with the whole of life cycle statements. So here is where you think about defining your operational model, defining the reference architecture. There are musts and shoulds in here. I mentioned the 148 criteria. Identifying the people and building the people and capabilities. So for example, agencies must identify and assign AI roles to ensure a diverse team of business and technology professionals with specified skills. So you must have your right subject matter experts, scientists, doctors, depending on your application. Another must, you must build and maintain AI capabilities by undertaking regular training and education of the end users, staff and stakeholders. Again, using the AI to find out the use cases and then using AI to build it and maintain capabilities. How you're going to audit the AI. How you're going to provide explainability based on the use case. So explaining the AI system and technology used, including the limitations and capabilities of the system. May include trade-offs, costs and performance, what changes are made in the updates, how's feedback improving the system, is it static, is it learning, is it supervised, is it unsupervised, is it a pre-trained model that has certain constraints around how you prompt, whatever is specific to your use case. How you will manage system bias, how you will apply version control, or how you will apply version control watermarks, similar, I think. That's the whole of AI lifecycle. Now, what I'm going to jump straight into now is evaluate, because for me, that's a starting point. And I'm going to jump straight into the use cases. So I think there's a good use case here. Criteria 98. Perform explainability and transparency testing as per the requirements. So depending on your use case, depending on how you're going to use it, and I might go off script a little bit here and jump back and forward to a short 70-second video, which talks about a scenario that may need explainability and transparency. So how are you going to test that the AI outputs are understandable for the target audience, ensure diversity of test subjects and representatives of the representativeness of the target population, how you can ensure that testing the right information is available for the right user. Let's jump into an example of where you might need explainability and transparency. So this is, I'll go through in a little bit more depth on the next slide in the pragmatic tools, but this is an example of using an ethical AI risk matrix to determine what level of explainability is required. So I'll just put on a 70-second video now.
And how we would create that framework and put it into our ultimately Athena artificial intelligence.
Create an ethical AI risk matrix with detail for each project activity. Define the activity you are undertaking. Indicate the ethical facet and
if you want to learn,
okay, there we go. We got an ad in the middle of that.
Why? There's too much.
Topic the activity is intended to address. Estimate the risk to the project objectives if issue is not addressed. Define specific actions you will undertake to support the activity. Provide a timeline for the activity. Define action and activity outcomes. Identify the responsible parties. Provide the status of the activity.
The ethical AI risk matrix. And this is a project management tool that you can use in order to identify ethical risks in your AI project, assign those ethical risks to an individual who needs to take responsibility for mitigating those risks with a limited amount of time, but it has to have a schedule and it has to have some obligation to resolve them. But it enables a project to keep track of these ethical risks and to have accountability for how they're managed when that technology does go into service or operation.
So in regards to how we manage risk.
So I'll come back to that in the pragmatic tools on my next set of slides. And what I'm trying to illustrate there is okay, when do you need explainability? Again, depends on the use case. So if it is for a mission critical military scenario, for example, the understanding of that, how is the target audience trained to understand the data, and how have you set up your survey and your sample so that if you're assessing confidence scores, for example, of a targeting accuracy, knowing where the bias could be in there, for example. Going back to the PowerPoint. Is that sharing or no? I have to share it.
No, not yet.
That's sharing?
Yes, perfect.
Okay. So we looked at one of the criteria here inside of Evaluate. This process has 9 lifecycle stages. The whole of AI lifecycle governance is where we sit and say, okay, what type of model are we using? What are our use cases? We then go into the evaluate space and say, okay, what is it that we need to evaluate? And that explainability piece was just one of those. But I might spend a few more minutes going through more of those, because I think there's a lot of value in talking through some more of those actually. Let's go to what else we got here in the statements for test strategies. Confirming that I got the web page back up. So mitigating bias in the testing process. What do we need to consider here? Again, we use pragmatic tools, we use risk matrix, we'll come up with a plan to frame these into actions. So differentiating test data from formal testing, from the data used during model development. How do we ensure that test subjects involved in the development of the system under test are independent from those that need to be checking it? How do we provide testers and developers that independence? How do we use test-driven development, such as designing test cases on the requirements? And this is where I make that link. So if we have use cases based on digital engineering with the assistance of AI, the end user in the room, it's a very powerful way of being able to link down to requirements, how you want to form your model, and then it just keeps rolling out from there. How you'll conduct peer reviews, bias awareness training, pretty straightforward. Defining your test criteria approaches. So are you going to use statistical techniques, probabilistic, non-deterministic? a single test is generally not going to be sufficient. There's some good links here on general safety regulations. How you're going to perform baseline testing against a reference system, how you're going to consider metamorphic testing for systems that are continuing to learn. There are also many shoulds in this criteria, and these need to be considered in terms of your specific use case again. So this is where your risk matrix comes in. And just because the framework says it's a should, it needs to be assessed for your particular situation. Sometimes a should becomes a must. And there are some really good things in here. Okay, how do you identify limitations? How do you ensure that the methods measure coverage? How do you trace your tests against the use cases, the requirements, the design? What's your strategy for ensuring test adequacy? And this actually comes with a spreadsheet as well. There's a lot of good stuff in here. I think there's even training in this website. If we go staff training, implement training, questions about implementation. If you're outside of Australia or the public service, including if, there's training things that you can download here off the internet. Some really good framework stuff. So we've gone through one of the statements. Then we want to look at, there's multiple statements in here. We've got statement 26 to 30, all in the evaluate. And this is where, coming as a T&E manager practitioner, my mind always goes here. So right from the beginning, we should be thinking, what does good look like? What are we testing for? What do we need to be mindful and cautious of? And going through this upfront, not later. Soon as we know the use cases, we should be thinking about this. So how do we undertake human verification of test design and implementation for correctness and consistency and completeness? How do we conduct functional performance testing to verify the correctness of the system under test and any predefined metrics? And we're talking ethics today. So it's challenging without a use case to come up with these metrics. But as soon as you start deciphering your use case, your end users, and you know where in the decision chain you're planning to use AI as your advisor. I always see AI as the advisor, never the decision maker. AI is not a decision maker, it is an advisor. Is it trusted? Only if you know what you need to know about how you're using it and what it's doing, what is the data it's been trained on. How are you going to perform controllability testing to verify that human oversight and control and system control requirements? So how are you going to verify that the human is oversighting the right piece? That again comes down to unpacking against the framework, your specific use case, and where do you need to have your laser focus points. We went through the explainability one. That's one of my favorite, number 98. 99, how are you going to perform calibration testing? So how are you going to measure it across different operating installation conditions? How are you going to test it in that changes in calibration are detected? How are you going to test any outer range calibration? So if we apply it to ethics, what is calibrating the ethics? Barclay gave us a really good example of where he prompted the AI to vector a certain set of predictions and resulted in being biased towards a certain what was it, philosophy on how it answers the questions. So how are you checking that? How are you calibrating that? How are you performing logging? Again, this depends on your use cases. Logging might be a thing. Security reasons will require significant logging. How are you testing for safety, robustness, and reliability? This becomes very important. So the safety aspects of the use case. How are you going to test the computational performance of the system? How are you going to test safety measures through whether you do negative testing, failure testing, fault injection? How are you going to test for incorrect or harmful inputs? This is where the power of use cases becomes very important. And we talked about Ross Ashby's law of requisite variety. The system checking the system must have more variety than the system it's checking. So these are the things you must consider, especially once, you know, if you are thinking about using this in part of a critical decision chain process. How are you going to test the reliability of the output? Stress test it over what period of time? What are your edge cases? What are extreme conditions? Again, depending on your use case, adversarial testing, penetration testing might be a must, not a should. How are you going to test for conformance and compliance, whether it's policy, whether it's frameworks, legislation? How are you going to verify conformance against the organisation or industry-specific codes? So all of these need to go into your plan. I know Tom at the beginning mentioned the policy, and we talked about, okay, BCS, okay, what's the policy there, or other organisations, what policy do they have? How do you verify compliance against that specific policy? How are you going to perform vulnerability testing? I mentioned that one. And testing for intended or unintended consequences. So the user acceptance testing, very important, and scenario testing, another one of my favorites. So the power of linking baking the goodness into design. So the human AI team can come up with really good use cases and scenarios with end users there, with developers there, with equipment manufacturers, software manufacturers, all in the room. For anyone who's familiar with the N-choose-2 equation, the combination equation, humans have a diminishing return after 4 people, because N-choose-2, if you got 3 people, 3 2s is 6, you got 3 paired two-way lines of communication. If you got 4 people, it doubles to 6. So you go from 3 to 6 paired comms. If you got 5 people, it goes 10. So after 4 people, you get diminishing returns on being able to communicate. Add AI into the mix, and all of a sudden you can have hundreds of people in the room all entering information into a chat, which we were trying to demonstrate at the beginning, and then forming vectors and common themes, removing duplicates, so that all of a sudden your distributed situational awareness is much higher than possible without the AI in the human AI teaming. So all of these scenario testing must be considered. How are you using the actual AI for your particular use case? How are you going to validate the system with a diversity of end users? Do you need independent acceptance testing as well? So independent verification, again, depending on the operational context and real world scenarios. How are you going to do regression testing? Very important from V&V. Once you've deployed it, it's unlike previous where you then hands off, it goes over to the in-service folk. It's now an ongoing regression thing becomes very important. Given where I am with the time, I'm going to drop back to the PowerPoint now. And then I've got to hit share, don't I? Share, PowerPoint, share. Now you get a thumbs up, PowerPoint is sharing. Yep. Okay. So we've gone through the governance, the whole of lifecycle governance, and we've focused on evaluate, and we didn't really go into monitor much, but that's where we then plan how we're going to do the reporting, how we're going to do the ongoing monitoring against the evaluation criteria that we set. And there's a lot more here that you can take home afterwards and go through at your leisure. Now I'm going to go into the second part. So that was the framework. Now the second part is the tools. These are the pragmatic tools. So what I've referenced here is from Dr. Kate Conroy, Nee Devitt, Michael Gann, Jason Schultz, and Robert Bollier, a method of ethical AI in defense. This comes from the Athena case study and has 5 facets for a method of ethical AI in defense. Now, those 5 facets being responsibility, governance, trust, law, and traceability. So this framework it's a practical framework for embedding ethics by design in defense artificial intelligence. I mentioned it originated from the Athena case study. It's designed to support operators in meeting international humanitarian law obligations during targeting decisions. It links to the cybernetic model of feedback, adaptation, control loops, and governance. So the 5 facets and the QA mapping I'm going to talk about a little bit. Responsibility at the top there, who's accountable? Humans retain legal and ethical responsibility for AI supported decisions. And we said that at the start, and it's very important. They must retain that responsibility. The cybernetic link here is clear control nodes in the system, for the decision authority to remain human. That's where you use your unpacking of the framework to ensure that occurs. The QA implication of this, we must train operators to interpret AI confidence scores, for example, and when to override it. So that becomes very important in training the humans and testing the humans and how they interpret the AI. Moving on to the governance, how is it controlled? Well, the frameworks embedded from the early stages, it's very important, and depending on the use case, if it's a military use case, for example, it must support Article 36 reviews, compliance with Australian systems of control. For those not familiar with Article 36, it's the protocol to the Geneva Convention, where all new weapons and methods of warfare must ensure compliance with international law. In other words, Article 36 is legal review of new weapons for humanitarian compliance. The video I showed before, on the next slide, I've got a QR code. It's a full 36-minute video, and it goes through that in a lot more depth. Trust. So how can it be relied upon? Again, your version control. So we went through some of that framework where we can actually put that into spreadsheets, action, or whatever tool you use. Validation frameworks, bias minimization, user-centered design, bringing in the user. The ethics, the use cases come down to what is the end user using this for? How is the AI in the decision chain? The cybernetic link here is the system stability, reliable performance over time, building operator confidence. So as the model learns and the drift occurs, how is the reinforcement of ethics ensured? The quality assurance implication of the trust piece. So the validation against real world scenarios as part of the test and evaluation. That's why I start with evaluate. We must be thinking about that first before we build anything. The law, how can it be lawful? So designed to enhance compliance with international humanitarian law, for example, or Article 36 weapons reviews, or whatever is your particular use case. The cybernetic link there is the constraints inputs, so the legal requirements to act as the boundary condition for the system, the QA implication of legal compliance as a quality requirement, not just a compliance tick box, of course. And the fifth facet, traceability. So how are actions recorded? This comes to your reporting. That was the center hexagon, the monitoring, the ongoing V&V. Where are your end-to-end audit trails? Your data lineage, your model parameters, your performance metrics, and your decision logic. How are you recording and reporting and statusing those? The cybernetic link there, again, is feedback channel, full transparency, enabling error detection, correction, and learning loops. Depending on your use case, again, on how rigorous. Discipline over rigor is what I always stress. You must be disciplined for your particular use as opposed to rigorous for the sake of documentation. QA implication of traceability. This enables adaptive assurance over the system's lifecycle. So why is MIAD matter for cybernetic QA? It moves ethics from an external audit to an internalized control process. It embeds anticipation, reflexivity, inclusion, and responsiveness, the four innovative dimensions, into the operational QA loops. It supports meta QA by making governance itself subject to structured review. Now, I've got a QR code there as well, and that will take you to the website there, which includes some really good tools in there. There's the data ethics canvas, there's the AI ethics checklist, there's the ethical AI risk matrix. There's also a legal and ethical assurance program plan, draft data item description, which can be used for, contractors can use it, for example, when they're thinking about how they want to plan the type of AI that they need to build for your particular purpose. This slide will take you to a 36-minute video that goes into more depth of applying the pragmatic tools that I've just gone through today. Very good video. I recommend watching that. afterwards, and it includes a really good set of papers on the method for ethical AI in defence for Australia. Now we move on to the fourth layer of QA, the adaptive QA as a cybernetic process, inspired by Dr. Larry Kennedy. So adaptive QA as a cybernetic process. Is the system AI self-checking correctly? That's the meta QA. Meta being a Greek word for after. It's after you've done it, you've got to keep checking. Have we built the right self-checking AI system? What are the meta QA considerations? So from Larry's teachings, in those who've had the pleasure of doing the INCOSI QMI Systems Engineering Quality Manager course with Larry and Barclay. As Larry always says, zero defects as a meta commitment. Well, I'm adding it as a meta commitment now. Zero defects as an attitude, but also now as a meta commitment in meta QA. Work process analysis driving quality assurance, or the quality assurer, Larry's 5-step WPA process. Proving return on investment as the price of non-conformance. As Larry always says, it's the price of non-conformance, the cost of quality. Preventing the Mr. Guess and What scenario for those who've done the course. A few things I want to tease out a little bit more here. So a culture of keeping the promise, the zero defects as a meta commitment. Treating quality as a promise that you're ethically obliged to keep. Zero defects isn't perfectionism, as Larry always says. It's an attitude that every customer matters. As Larry asked in the course many times, how many worms in the sandwich is too many? One, of course. Use this keeping the promise culture as your top level of acceptance criteria for QA, for the QA program itself. The process of processes assurance, the WPA, work process analysis driving QA of the QA, auditing your QA system with a same 5-step process you apply it to products. So describe, research, cost it up, decide, do a reality check, course of action analysis before you implement. Use it to design your QA framework, not just the product flow, and monitor every process for defects. And the economics of meta quality, proving the ROI via the price of non-conformance, evaluating the QA system by its economic impact, measuring that price of non-conformance quantitatively. As Tom said in his presentation, if you can't come up with a quantitativeness, use AI. It is really good at that. And the cost of doing things wrong versus right. Very, very important. Right? This is a powerful justification of QA. Also, a grounding quality as fulfilling requirements of what, how much, when, and how this applies to your assurance process. To summarize this fourth layer, in terms of quality control acts on the product, inspects output, finds defects. The quality assurance regulates processes. So the layers 1, 2, and 3 we went through, the audit, validating, ensuring repeatability. The quality management becomes the meta QA, the fourth layer, the regulating the regulator, reviewing the QA system, aligning with ethics and purpose. Leadership and ethics, governing the system's meta behavior, ensuring system viability adjusts governing logic. AI and modern systems, they can be both regulated and the regulator, so they need this meta QA and ethical constraint in order to answer the call for ethical, urgent call for ethical reflection, as we mentioned at the beginning. So bringing it all together now, this is where I would have come to the output we got from the audience. I'll come back to the simulated output and say the audience's point of view. Well, this is a artificial response today, but was accountability and responsibility. Participants stress that legal and ethical accountability with QA and enforce clear responsibility change to prevent blame shifting. I think we've demonstrated that can be done using frameworks, using the pragmatic tools. Oversight and human authorities from the audience, strong signals favouring humans retaining ultimate authority. Yes, absolutely, and demonstrated today. Transparency and auditability. So the black box AI, again, I think we addressed that through the framework, through the pragmatic tools, and ethics beyond compliance. So QA must itself must integrate human values and conscience, and that is what we talked about. How do we get there? And it all depends on your use case. So before I wind up and open up for some Q&A, 5 key takeaways to take home from today. Ethics can't be outsourced. Automation must be embedded in the regulatory design. In adaptive or AI-enabled systems, assurance must itself adapt. Deep learning magnifies both predictive power and ethical risk. Well, the meta QA is the amplifier turned guardian that keeps the regulator itself honest. The fourth order QA, the meta QA, helps maintain that relationship between compliance and conscience when reliant upon the autonomous regulator. And hopefully, you've gotten some value out of today, and that the Australian government architecture, coupled with the pragmatic tools presented today, are just some of the actionable methods that you can apply to the 4 layers of QA to ensure responsible, legal, and ethical use of artificial intelligence. Thank you for listening to my talk today.